let's get the converse, inverse, and contrapositive of the given statement, conditional statement. If a triangle has at least two congruent sides, then it is an isosceles. So our hypothesis, a triangle has two congruent sides, and our conclusion, it is an isosceles. Again, it pertaining to the triangle, to our subject triangle. Now, let's have the converse Q then P. So we interchange or switch the P statement and our Q statement. So we have if a triangle is an isosceles, then it has at least two congruent sides. Okay, so that is our converse. Now, for the inverse, we have to negate our P statement and our Q statement. So, if a triangle has no or doesn't have at least two congruent sides, comma, then it is not an isosceles. Ends with period to make it a sentence. For the contrapositive, so we negate or we switch and negate the given conditional statement. So if a triangle is not an isosceles, that is our not P, then it doesn't have at least two congruent sides. Now let's define the truth value of each statement. For the conditional, if a triangle has at least two congruent sides, so if we put that into mathematical symbols, so we have n, the number of sides, is greater than or equal to 2, then it is an isosceles. So this is said to be a false statement. Why false? Our counterexample for that is the equilateral triangle. Because equilateral triangle is also at least two congruent sides. In fact, we have three congruent sides for equilateral, but it satisfies the at least two congruent sides. So our counterexample for that is the equilateral triangle. Now, for the converse, if a triangle is an isosceles, then it has at least two congruent sides. So this is true statement because an isosceles has at least two congruent sides. Next, inverse, if a triangle doesn't have at least two congruent sides, then it is not an isosceles. Again, this is true statement. Contrapositive, if a triangle is not an isosceles, then it doesn't have at least two congruent sides. So again, the equivalent or the logically equivalent of conditional is the contrapositive. So if our truth value for the conditional is false, therefore this is also false statement. Our false statement. Our counter example is the equilateral triangle. Now let's have this one. If an angle is right angle, then it has measure of 90 degrees. So our if statement, an angle is a right angle, then our then statement, it has a measure of 90. So this is our P statement and this is our Q statement. Our pronoun it is pertaining to an angle. That is our noun. Let's have the converse. Q then P. So we have if it has measure of 90, it is pertaining to an angle. If an angle has a measure of 90 degrees, then it is a right angle. So we switch the hypothesis and the conclusion to get the converse. Next, to get the inverse, we need to negate the hypothesis and the conclusion. So if an angle is a right angle, so the negation will become if an angle is not a right angle, then it doesn't have a measure of 90 degrees. So that will be our inverse. For the contrapositive, we switch the hypothesis and conclusion, then negate both. So we start with the conclusion, negation of the conclusion. If an angle doesn't have a measure of 90 degrees, then it is not a right angle. So that is our converse, inverse, and contrapositive of our conditional statement. Now let's identify the truth value of each statement. Conditional, if an angle is right angle, then it has a measure of 90 degrees. So this is true statement because right angle always measures 90 degrees. Next, if an angle has a measure of 90 degrees, then it is a right angle. So this is also true because all right angles measures 90 degrees and all angle measures 90 degrees is also called as right angle. Next, the inverse, if an angle is not a right angle, then it doesn't have a measure of 90 degrees. That will be a true statement. For the contrapositive, if an angle doesn't have a measure of 90 degrees, then it is not a right angle. This is also true statement. So again, we have true for the conditional and true for the converse. So since the conditional and the converse are both true, we can form a biconditional statement. Biconditional is formed using if and only if. So we have P, if and only if, Q. Our P statement is an angle is right angle. Our Q statement, it has a measure of 90 degrees. So to write the biconditional, P statement, an angle is a right angle if and only if it has a measure of 90 degrees. So again, the biconditional can always can form if our conditional and converse are true. They are both true. If one of them is false, we cannot form biconditional statement.